Under the direction of the Air Force Missile Test Center, the Sperry Gyroscope Company is managing the design, development, test, and conversion of the first two advanced range instrumentation ships, Aris-1 and 2. These mobile stations will collect terminal data on re-entering nose cones and decoys. They will extend coverage of the Atlantic missile range to over 10,000 miles. Among major items of instrumentation are this stellar inertial navigator, similar to the one aboard Polaris submarines. It pinpoints the ship's position. The long-range C-band radar tracker is used to obtain trajectory, signature, and splash point data. The dual polarization system is actually two radars in one. This single 40-foot antenna is shared by the L and X-band radars. Both these systems also are dual polarized. They are used to study characteristics of re-entering objects. Finally, this is the 30-foot telemetry antenna. The broadband system provides 4 dual polarization data links. Summarizing briefly, the program began in July 1961 with breakout of the General Callan, a C-4 troopship from the Hudson Reserve Fleet. The 520-foot Callan was moved to the Brooklyn shipyard, where she was joined 3 weeks later by the General Harry Taylor. In the months following, the ships were dry docked for inspection and painting. Unwanted topside structures were removed, and remaining ones were reconditioned. Internally, space was cleared for installation of new equipment. By March of this year, rip-outs had been completed, interior foundations installed for the radar and telemetry mounts, and new superstructure in the form of the radar room and navigation center had been added. Design of instrumentation equipment progressed concurrently with work on the ships. By January of this year, hardware began to take shape. The radar electronics and antennas at Sperry Gyroscope Company, the 1206 computer at UNIVAC, and communications equipment at ITT, to name but a few. This latest film report covers progress from April 1962 to early June. Here at the Sperry Antenna Range, assembly of the C-band radar antenna was completed in March. Following assembly on the ground, the 30-foot dish, weighing 2.5 tons, was then mounted on a test turntable for bore sight and pattern measurements. Adjacent to the turntable, this shelter houses equipment for automatically recording antenna pattern measurements. Bore sight adjustments and pattern measurements met test specifications. RF tests on the 30-foot dish were satisfactorily concluded by the beginning of June. This is the LX band reflector as it is prepared for installation atop the test turntable. Here, the 40-foot reflector has replaced the C-band dish on the test stand. The screened outer section of the dual-frequency antenna is used for the lower L-band radiation. The center portion of the dish reflects both L and X-band signals. The C-band antenna will be moved by truck and then barge to the shipyard. At AMF in Stamford, Connecticut, work is progressing on the radar antenna mounts shown here on April 23rd. This is the elevation yoke for the C-band radar. It will support the trunnion, elevation equipment case, and reflector. The yoke in turn will be mounted on this pedestal. the pedestal will house the train bearing, bull gear, and drive motors. By the middle of May, work on a second yoke and pedestal was well underway. The first pedestal was mated with its yoke on May 15th. Shortly thereafter, the elevation equipment case was installed. The mounts will be transported by barge to the shipyard. By the end of April, fabrication of the barbettes to support the Callan's antenna mounts was completed. Note the foundation ring atop the barbette. Aboard ship, A-frames had been erected to guide the landing of the 20-ton barbettes. Here, frames are installed to guide the C-band barbette, which will be mounted behind the Navigation Control Center. Internally, progress continued on installation of cable brackets and preparation of equipment areas. This is the computer room. Pipes, air conditioning ducts, insulation, and cable runs must be near completed before equipment is installed. The wooden frames you see here are mock-ups of the control and designate consoles in the Operations Control Center. Cables are routed to the consoles beneath the room's false deck. The mock-ups permit detailed cabling prior to equipment delivery. After fabrication in the yard's plate shop, the telemetry barbette was moved down the pier to the Callan. This is a good view of its internal construction. Note the heavy support members. They assure that the barbette will be capable of supporting the 85-ton weight of the antenna mount. A major design problem has been to maintain resonant frequencies of barbettes and mounts high enough to avoid interaction with vibration generated by the ship's propeller. Here the barbette is swung over to position atop the telemetry foundation. The foundation ring atop each barbette has to be perfectly flat to mate with its pedestal. Final machining of the rings had to be done after they were installed because the heat from welding would distort them. During this reporting period, daily manpower assigned to ship conversion increased to more than 800 men. Landing of barbettes was completed early in June. As work on the ships pressed forward, assembly and test of equipment at various subcontractors was progressing rapidly. At FXR in Long Island City, components of the LX band radar transmitter were being assembled. These modulator cabinets contain pulse shaping circuits for the L-band radar. Here a vacuum chamber is being used during oil filling operations on one of the high voltage transformers. At Avco in Cincinnati, Ohio, the program to produce the C-band radar transmitter is also moving forward. System number 1, shown here on May 1st, was then nearing power-on tests. Major chassis and cabinets had been completed. Here a technician replaces a snap-in resistor in the klystron modulator unit. This is the performance monitor and beacon cabinet. Upon completion of factory acceptance tests, the transmitter will be sent to the shipyard for marriage with the C-band mount. At ITT laboratories in Nutley, New Jersey, units of the telemetry, timing, meteorological, and communication systems are nearing completion. Here a test and monitor cabinet for the radio communication system passes inspection and acceptance tests. At Ford Instrument Company in Long Island City, units for the Operations Control Center are nearing completion. The unit in the foreground is the Master Control Console. Behind it is the Designate Console, which will control sensors during experiments. The white indicators show the orientation of the radar mounts. At the Navigation System Shore Test Center in the Sperry Marine Division, installation and checkout has been completed. This test area, duplicating the layout in the ship's nav center, has already served a valuable function in pointing out structural and cabling problems before they were encountered aboard ship. At the rear, the Mark I SINS inertial navigator has been suspended from its special support structure, a duplicate of that aboard ship. The star tracker will be mounted directly above it, providing direct data linkage. Here, RF tests are being performed on the C-band tracking horn, and in the background on an L-band ferrite isolator. The first group of microwave components for the radars have already been delivered. The C-band monopulse system uses this unique waveguide comparator behind the C-band horn to obtain range, azimuth, and elevation data. Inspection and test of components are being performed in a special test area, maximizing utilization of equipment and skills. A second shore test center has been established to check out and marry the computer and central data conversion equipment. The facility will also be used to prove out computer programs. This shore test center has been in operation since May. Here, tests are being run on the UNIVAC computer system. Instructions are fed to the computer through the paper tape unit. Information is processed in the 1206 computer. The system includes magnetic tape units for auxiliary data and program storage. The units presently in this test center will eventually be installed aboard the Taylor. The central data conversion equipment is located adjacent to the computer. Phase 1 tests have started on this equipment. Near the end of May, the Callan went into dry dock for the second time. Final underside cleaning and painting were performed. At the same time, transducers for the sonar sounding sets were installed and major repairs were completed on the stern frame. On May 22nd, the ships were inspected by General Bernard Schriever, Commander AFSC, and Major General Leighton Davis, Commander AFMTC. The group was accompanied by Dr. Carl Frischie, President of Sperry Gyroscope Company. Following the ship visit, a special presentation was made on program history and status by the Sperry System Management Group. By the first week in June, barbettes, davits, and the stack had been installed aboard the Callan. Cable pulling and preparation of equipment areas was in full swing. In the coming months, the results of planning, design, and development will become dramatically visible. Management emphasis will shift to the complex test and integration of the 958 pieces of instrumentation being installed aboard each ship.